Next part is the VNF Descriptors and VNF Package. Again, my name is Thinh Nguyenphu. I'm from the ETSI NFV Solution Working Group Vice Chair. I'm here as also as a Nokia Bell Lab member. You just heard from Joanne talk about the key component at the design time, which is the VNF Package and VNF Descriptor. So I will take the next 20 minutes to go through how important, what the concepts are, and how the modeling of the VNF Descriptors and also the VNF Package. Okay. Sometimes I use short terms like solution or SOL001, which is the VNF Descriptors. But SOL001 also, by the time it officially have publications, it will also cover the network service descriptors. All right? So that's a small minor error, but today, the focus on the VNF descriptor, so that's why I put it there. The second thing is the VNF package, SOL004. It's already been published, and it's available, and people are currently using it and implementing it. All right. So the first parts, VNF descriptors, you've seen this slide before, and you probably heard many, many times. But what's very important from a design time, this VNF descriptor is for the VNF providers, the vendor that write the software who want to provide the application. That's like a recipe, okay? The recipe, how he built it, connect together, how he see his VNF go through the life cycle of management and all of that. So it's very important from a VNF provider's point of view. So that's very important things. Here, the VDU, we all talk about this acronym VDU, but basically compute, storage, internal, and software image. That's the basic part. And then we have different connection points and internal virtual link, and then the deployment flavors. The deployment flavor is, someone could see this as a complex part, but it's play a very crucial from a VNF providers and service providers to be able to design the service and look at it from the service point of view, how do you scale it, and what type of VDU you need for a certain size of a service to a complex size. So that's the deployment flavors. So I already kind of giving the basic parts, and most of you already understand the VDU, the storage, the internal connection point, software. The internal virtual link, this is the link how to connect two VNFCs. That's the component of the VNF, right? How they connect together and communicate. And then the external connection point. So those are the basics part. But this slide, the purpose of this slide is really dive in a little bit more detail of what the deployment flavor is. So deployment flavor really contains 5 major components. First one is called the instantiation level. From a VNF providers, when they design the VNF, they have to think of it, how big, how small, what environment I'm going to put this out for VNF, what type of customer. You don't want to design a VNF and a VNF package for each type of deployment flavor, all right? So you want to be able to design from small to large, complex to simple. So that's the concept we call it instantiation level. That's giving you amount of the VDU that you need to instantiate for each type of level. And here, let's assume the deployment flavor here, I'm talking about small, medium, and large type of network or type of transactions. If my VNF is a database or call processing, I can do a simple concept, call per second, small, medium, and large. So from a small, I may have different type of VDU, different type of resources, and different connectivities. And therefore, each of the instantiation level and the deployment flavor, I may have additional VDU profile to configure that set of VDU, the compute, storage, and connection point. Also, the virtual link profile. I may have unique virtual link profile for that specific flavor and specific to that instantiation. And then also, because deployment flavor, like I said, simple to complex. On a simple, I may have a lifecycle operation, very basic, like instantiate, query, and terminate. No scaling, right? That's very simple. And then I have a complex where I have, instantiate, query, modify, scaling, healing. So each of different deployment flavor may have different lifecycle operations. So therefore, it has additional different lifecycle management attached to that. All right? And then different scaling aspect, because different flavors, vendor may design the simple that can only scale up to certain limits before they have to do a complete medium flavors. So that's also part of the scaling aspect and the calculation that the vendors, the software vendor, prepare for that. One thing important to note, each of these flavor may have a different topology of different connection points, different aspect, all right? So that's very important from a concept of this deployment flavor. This is a very busy slide, but it serves a couple purposes. One is for your reference. Second, it's give you an important data types or types, the OASIS Tosca types that working group adopt and define. First, when we take the IFA 11, which is the information model for VNF descriptor, and we have to look at that and say, okay, what language or what service descriptor language do I need to use? The decision back a few years ago is to use OASIS Tosca language to build that service template, to build that VNF descriptor. So we began to work with OASIS Tosca to model each of our components of the information models. Second, it's just a reminder this is still a working draft. It's not completely finished, so things may change, but it's stable enough that you can see some of the example and how things work. All right? And then finally, what we use is that our base spec is based on simple YAML version 1.1 and 1.2. The complete spec is referenced to 1.2. And we recognize OASIS Tosca Simple YAML Profile 1.2 just released this year, recently. So we know there is a time for vendors and orchestrators and parsers to build on a new additional feature of 1.2. So to ensure that we can have a support and beginning to deploy this, so we can also support version 1.1 in one condition is for single deployment flavor. The reason why we need the 1.2 grammar and language because of the complexity of multiple deployment flavor. So if you have a simple deployment flavor, you can use version 1.1, which is available. The specs of the YAML spec is available last year, and examples also exist. All right. This is an overview of the model. So let me first start from the outside square box or the dashed line. That is the modeling of the VNF descriptor. The first node is, we call it the VNF. This VNF is important VNF. It represents the entire behavior of the VNF. It has, we define what we call in OASIS Tosca interface. That is the interface that exposes or make it available for all the VNF lifecycle management. So all the ETSI LCM operation on SOL 3 is now can be supported on this interface from a modeling perspective, all right? And it has the basic informations and properties of the entire VNF, all right? The next part is the VDU. When we designed this, so the VDU here, like we said before, it consists of compute, connection point, and storage. So when we modeled this, we used a new node type called VDU.compute. That's the compute functions or the compute node, the manage mode, and OS Tosca term. It can support its own artifact software images, or it can have persistent storage that you can have out here. So we have a VDU virtual storage. So you can define your own storage here, and then also the VDU, the connection point, VDU CP. That's the connection point, the internal connection point of the VDU. So that's your VDU, okay? We look at the language in Oasis Tosca, and we came to a conclusion that we can use the powerful of Oasis Tosca substitution mapping concept to create the concept of VDU. So if you download the specification, you can look at the annex and how a VDU can be realized by using substitution mapping in Oasis Tosca. And then we have the connection point. There's two cases of the external connection point based on IFA specifications. One, you may have a connection point, internal connection point that re-exposed as an external connection point, all right? In that case, we use the same internal connection point and then we re-expose it out. In the other case, where your external connection point also connect to an internal link, in that case, you have to have a node called a virtual internal link, VNF virtual link, and then your external connection point is associated with it, okay? So these two parts, so when you design your VNF, the basic VNF, if you decide that, hey, my VNF is re-exposed, then you may use this node types. But if you go, your VNF is connect to some of the internal link, virtual link inside of multiple VNFC, then you would use this node type, all right? The specification will give you the hints which node type you use. So the best way for me to do this part, next couple slides, is to go through a quick example. I'm not expecting you to understand all the basics of Oasis Tosca, but what I have here is the actual service template of Oasis Tosca, single YAML version 1.1. Because remember, we are doing single deployment flavor. And here's the example. But if you can look at here, there's three parts. We define the node types, the topology template, and the node template. Those are key sections within the VNF service template. Here, we define the VNF. Of course, I derive, the keyword here is derive from. So Sole Solution Working Group 001, we define, standardize what the NFV.VNF node types shall look like. So for vendors, we're going to build that. So we derive, so we build our VNF, we derive from that template. So you can see that is a standard, right? And also in here, one of the key parts is the interface. So that exposed what the lifecycle management of that VNF look like. And the rest of them, I will go through the detail in the next few slides. But that's the important part. So the first part, compute, storage, and connection point. And you can see, you can follow through the model I showed you earlier and how it represents in the actual service template that's standardizing right now, right? So here, my VDU.compute, that's the types I define, right? And that's the DB backend, that's just a name, the ID that me as a VNF provider call it, all right? Now, so this is to follow the arrow. If you look at here, that's the internal connection point, VDU.CP, right? So that's the internal connection point here. It virtual binds, so it's bind to the server or the compute nodes. And the same thing here, on my compute nodes, I also say I require to have some kind of storage. So that's the MariaDB storage. And again, I used standardized types from ETSI. So that's how the representations for quote unquote a VDU. All right, compute, storage, and connection point. And here, remember internal connection point in the example, I also have the internal connection point connect to the internal link, right? That's just the example here. So this example show you how an internal connection point is representing or associated to the internal virtual link. And notice again, we standardized the VNF virtual link types. So each of these are model unique for each of the operations of the node. Same thing here, external. In this case, again, it's re-exposing the internal connection point. So I used the right VDU types, VDU.connection point types, right? So that's the representation here. One of the important things when we work on this Oasis Tosca, people say, well, why don't we just do just a simple data model, just everything data types, because that's what we really do. But that's not good enough, because from a VNF providers, I'm speaking as a VNF providers, we want to be able to have a rich language to be able to express how you want to lifecycle management this part of this VNF, right? Because once we build and design and test it and have a standard service template that any third-party VNF manager or orchestrators be able to understand and be able to acquire different resources and managing it. And one of the key things is the interface. Oasis Tosca use the term interface, but it's basically, think of it interface/operations. So we spent quite a long time and built this part correctly, right? And one of the things important in lifecycle management is we understand that every VNF could be simple to complex. They have different scripts. They have different behaviors. It may require additional pre-works for a VNF manager or a NFVO to prepare that part. So we want to make sure that we have abilities to allow like different input parameters right here. And on a different use case, like terminate, we have a different script to run that. So that's important from a VNF providers, okay? So this is modeled inside the VNF. So that's a quick snapshot of how the VNF descriptor, based on Oasis Tosca, is modeled, right? And just take a pause here. Our goal also, when we start working on the network service descriptor, we're going to try to use the same design pattern consistently across. Of course, network services may have different types and so forth, but we want to make sure we consistently design the same pattern so that it's easy. From a summary of the different work here, the first part, the first milestones, is the stable draft of the VNFD, the descriptor part of solution 001, is May 17, just less than a month here. And then the complete specifications is on the end of this year, or I'm sorry, September end of September, then we officially publish it. That's including the VNF descriptor and network service descriptor. So that's quickly, and I have quite a few more minutes quickly to run through the VNF package. VNF package is also very important because that's what we need to delivering to, from a VNF provider delivering to the customers, right? Without that part, the automation may not work very efficiently, and interoperabilities and so forth. The VNF package has some enablers. First enabler is standardize the package format, standardize the structure of what, where, and how I put the descriptor, how I put the artifacts, and how I protect those artifacts. And that's very important also. So I'll skip this. No, let me go back. There's a couple of things that people kind of misunderstood sometimes. The VNF package, also very important, is not just to onboard process to NFVO, but also the VNF managers be able to fetch specific parts or the entire VNF package also, and be able to fetch only the descriptor or fetch only the artifact, specific artifacts, okay? And also here, we choose to use Oasis Tosca CSER specifications within Oasis specification to standardize the format. And then we add additional things such as security, the manifest files, and so forth. So that's part of the solution 0004. And then finally, since this solution 004 is published, I believe last year, end of last year or earlier, and during the maintenance, we also get feedback, and this is a good example how we work through open source communities and other communities. They come to us and present, they have a use case that they need to be able to add third-party artifacts from open source, such as ONAP, right? Because it's not just ETSI artifacts, but how we be able to allow additional third-party artifacts that may require. So we define an extensions, and we began to work on building the registry so that the third party can go and register that, hey, that tree is my third party, and I'm building this from ONAP. And then ONAP can build whatever artifacts they design. But at least we know, when we look at the specs, the descriptor for the VNF package, we can know where they come from and what artifacts come from where, and so forth. So that's the end of my presentations, and I know I'm running out of time. So I would just prefer not to take any question, and if we have time at the end, I will take questions. Okay? Thank you.